Hey everyone, it's me, Miss B. And in this lesson, we're looking at the Unit 6, Lesson 6 cumulative practice problems. And this is for illustrative math geometry. Now, when we look at this first question here, um, it kind of asks you to summarize the whole lesson. So I'm actually going to leave this one to last, and I'm going to suggest that you write your own explanation for this, because hopefully after I explain the process that we go through, you'll be able to actually write your own understanding of what the completing the square process is. So I'm probably going to leave this one up to you, but at the very least, I'm going to leave it until last. So if you're looking for question one, I'm going to say that I'm doing this one last, so doing this last. Use your own um, understanding. And I might also say, well, mostly I'm just putting that because I know that not everyone actually listens to what my explanations are, and sometimes they just watch or they read the captions. So if they didn't hear me talk about it, they'd be like, why is she scrolling past? Well, it's because I'm doing it last. So we're going to then start with number two. Match each expression with the value needed in the box in order for it to be a perfect squared trinomial. So what we want to do for our process was really to, we're dividing our linear term in half. And I made this pen really thin, and that's kind of bothering me. So divide the linear term by 2 and then square it. That was our process, is to divide it by 2 and then to square it. So if we look at each one here, 8 divided by 2 is going to give us 4, and then 4 squared is going to give us 16. So this one actually matches with the one that's right across from it, this one right here, 16. Now with B, we're going to take 20 and divide that by 2. That's going to give us 10, and 10 squared is 100. So that means that's going to line up with this one right here. I'll make this a thicker line too, since I did that on the other one, because that's going to bother me. Okay, for C, when we take negative 16, half of that is 8, and then 8 squared is going to be 64. My 4 is a little not super visible there. So 64, maybe that's a little easier. So this one is going to match up with 3. And then that means that this very last one should be 20.25, but let's see if that works out. So we may have to do some calculator work here, but that's okay too. So we're going to start with 9 and dividing it by 2. So that's going to be 4.5. And then we're going to look at 4.5 when we square it. So I am going to plug that in a calculator just to double check. But because it's not a perfectly whole number, I imagine it's not going to give me a whole number when I square it either. That's generally how those things work. 4.5 times 4.5. And if you want to double check the work yourself, yep, it does give you 20.25. So this one matches up with number 2. All right. Not too bad so far, just some matching stuff. Let's keep it going. For this next one, we want to find the center and radius of the circle represented by this equation. And in order to do this, we're going to actually have to do completing the square twice. So I might even use number 3 here. I would use this. This is going to be a good example for what to do for question 1. So when we come back to it, we might just use some of this for it. So we want to write I'll kind of write what I'm doing and then write some explanations next to it. So I'm going to reorder this so that I have room to do this work. I'm going to say x squared and then plus 4x, and then I'm going to leave myself a blank because I know it's going to become a perfect square trinomial because I'm going to make it into one. Then I'm going to put my y terms, so y squared, the negative 10y or the minus 10y, and then plus and a blank because I'm going to put a number there. Now this 20 here, we're going to subtract from both sides, and that's going to move to the other side of the equation. But I have to do two more things. I put two blanks on the left because I'm going to add numbers there. That means I have to put those same blank spaces on the right, because if I don't add those numbers also on the right-hand side, this equation is no longer going to be balanced and my answers just won't be correct. Like it won't be the same equation. So the process we did in the one above, where we divided the linear term by 2 and then squared it, that's how we find these perfect square numbers. And so what I like to do is have my students set up parentheses down below, because the number you're dividing here by 2 is what's actually going to go inside this piece squared. So if we're looking at 4x, and I'm going to take 4x and divide it by 2, maybe I'll mark this out in, show this in red. So I'm going to like divide this by 2 and then put it here. And then that number squared is going to go up here. So this divided by 2 is going to give me positive 2. So both the sign and the number are the same. And it just so happens that 2 times 2 is the same as 2 plus 2. So this number also becomes 4. And I should be adding 4 to both sides. So as soon as I fill in that blank there, I'm going to fill in my first blank on the right-hand side and say that one's also 4. And then we're just going to repeat this process for the y terms as well. So we're going to set up some parentheses, squared. We're going to now look at what we have over here for y, this one, and divide it by 2. That's going to give us this number here, which then we're going to square and put in this blank. So that's going to create y, and half of negative 10 is negative 5. So this is going to be y minus 5, and 5 squared is 25. So that means on the right-hand side over here, not 5, 25. So now I wrote this really spaced out, so you don't necessarily have to write it this spread out, but we are going to add all of those three things on the side together. And those are going to create, let's see, 4 and negative 20 and positive 25 is going to give us positive 5, and then plus 4 would give us 9. So really, if I write this all together, x plus 2 squared plus y minus 5 squared equals 9. Now, I can actually kind of read my center and radius from this. But one last step that might make it easier is, instead of 9, if I wrote this as a number squared. Now, I cannot just say, I wouldn't say that I'm going to take the square root. The square root is how I'd figure out what this number is, but you can't just take the square root and say, oh yeah, it's 3. You need to write it as 3 squared. That's the way I represent it, just to show myself, like, oh yeah, the radius is 3. But if you wrote that it's equal to 3 and you didn't put the square on it, it would be wrong and you would not get the points for it. So if that's something that's a little difficult and you keep kind of forgetting that, I would just stick with using the 9 instead, and just mentally square rooting it when you go to find the radius. Especially on Canvas quizzes, I know that it gets a little difficult to enter sometimes when something is being squared, but just enter the whole number on those. But I like to kind of write it this way for me just so I can see it. But, you know, if your teacher does it differently, please do it the way that they're instructing you to do it. So here I would then say center. We're going to read this from the parentheses there, but we're switching signs because it's normally x minus h and y minus k. So this is going to be -2. And then that -5 is going to give us +5. And then the radius is 3. So my center and my radius, that's my final answer here, is -2, 5 with a radius of 3. That is the process of completing the square. So we reorganized, we found our missing pieces, simplified each side, and then we read our numbers. Okay. That's going to then bring us to the back of the page. We're going to select all expressions that can be factored into a squared binomial and then talk about how we know. Well, we want things that follow this pattern. So I'm going to kind of write out what our pattern is. If I have ax plus b, and I take this and I square it, it's going to provide me a couple things here. Now, I actually don't have any expressions here that have a coefficient other than 1. So instead of ax plus b, I'm just going to use x plus b. When we square this, we would have x squared, and then it would end with b squared. And the middle term is going to be 2bx. Now, if we had a involved, then that a would end up being here as a squared, and then 2abx in the middle. But for our sake of keeping things simple, we can use just b here and kind of look and see, well, I want something on the end that's a perfect square. I want a perfect square at the beginning. And then in the middle, I want double whatever the square root of this was. So that's what I'm looking for. Looking for start and end with, I'm going to say a perf, not pef, perf square. And then I want middle is 2 times square root of end number. So we would do the square root part first and then multiply it by 2. So that's how we're going to check this. That's kind of my mental checklist here. So select all that can be written as a perfect or a factored square binomial, and I'm probably going to write them as factored binomials as well. So begins with a perfect square, ends with a perfect square, and is 2 times the square root of 1 here in the middle. Absolutely, a can be written as a squared binomial. This would be y plus 1 squared. For b, begins with a perfect square. Now, the end doesn't quite look like a perfect square, but I assure you it is. 25 is a perfect square, and so is 4. If we square rooted this, not equals, I would say this would become 5 over 2. And if I doubled that, becomes 5. So b actually is able to be written as a squared binomial as well. This one would be w plus 5 over 2 squared. Now, it's not asking you to do all of these written in the squared binomial form, but I'm just showing you what it would end up as. So let's look at C. Does C end in a perfect square? Absolutely not. 5 is not a perfect square. So right away, disqualified. D. Does D end in a perfect square? 25. Yes, it does. Begins with a perfect square. And is 10, is that 2 times the square root of 25? Well, the square root of 25 is 5. It absolutely is. That's going to mean, excuse me, we can write this one as x minus 5 squared. Because that -5, when it gets squared, would give us positive 25. So it's okay for our middle term to be negative. That just means we put a negative in our squared binomial. That's going to then bring us down to E as our next option. So is E going to work here? It's going to bother me that that's not in purple. I wanted to alternate colors. This is the same thing as the one above it, except the middle term is positive. So this one works also, because 25 is a perfect square, and so is x. It just means we're going to have plus in the middle. So x plus 5. And that's going to be squared. Last one. 40. Alas, 40 is not a perfect square. So F, well, I meant to alternate colors. That's supposed to be red. F is not a perfect square because 40 is not a perfect square. So it needs to end in a perfect square number in order for this to work. And that's number 4. Then we're going to have number 5. We're skipping number 6 and going down to number 7. And I know number 7 is going to be pretty easy to do, or it's going to be quick at least. So number 5 here says an equation of a circle is given by this. Apply the distributive property and rearrange the equation so one side is 0. So this is kind of the opposite of what we did in lesson 6. This is actually what we did in lesson 5, showing that like, hey, when we multiply these out, this gives us another way of writing a circle. So let's just show that work. So I'll use my thinnest marker here so I can show all of it. So x plus 3. This is now going to become x plus 3 times x plus 3. And then we have y minus 9 times y minus 9, and that's all equal to 5 squared. I'm going to say 5 squared is just already 25. So this becomes x squared plus 6x plus 9. If I'm showing all of my work, it's because I'm distributing here and here, and I'm only skipping writing the in-between one where I would have plus 3x plus 3x. I'm just jumping right to the plus 6x, so I hope you don't mind on that one. Same thing with y. We're going to distribute the y first and then the -9. This would give us y squared minus 18y and then plus 81 is equal to 25. They want us to rearrange it so one side is equal to 0. So that means we are going to take this and subtract 9. And we're also going to subtract 81. So here's my other side of the equation. I also have to subtract 9 and subtract 81 from both sides. Oh, no, I'm so sorry. Wow, I had misinterpreted that. I read that completely wrong. I read it out loud to you completely right, but I mixed myself up there. One side being 0, that means the 25. Silly me. Okay, we're gonna subtract 25. So I'm gonna kind of just add that on the end before I combine any like terms. I'm gonna kind of rearrange things a little bit here, still showing I'm keeping it equal. So I'm gonna have x squared plus 6x. Then I'm going to write my y squared minus 18y, and then I'm going to write my plus 9 plus 81 and minus 25, and this is equal to 0. That way, all of my numbers there, I can now just kind of use a calculator and combine all of them. I always like to check myself on arithmetic, so no shame in using a calculator. 9 plus 81, that's going to give us 90, and 90 minus 25 is going to give us 65. So we would have x squared plus 6x plus y squared minus 18y plus 65 equals 0. And I guess if I'm doing this the right way, technically we should rewrite this a little bit so that you have x squared plus y squared plus 6x minus 18y plus 65 equals 0. In math, it is good etiquette. I'm just showing that I'm reorganizing. That I'm kind of swapping these two around, because it's good etiquette to write things with your highest exponent values first, and then to write the rest of everything in alphabetical order. So x does come before y, but our squared terms should come before the linear terms, or the ones that just have x to the power of 1. So if I'm going to be formal and fancy about it, I'm just going to kind of swap places with these two. So I only really need one of those arrows here, just showing that I'm moving it. But this here would be what they're asking for. So this is my answer. Hopefully not too bad. But I know my opinion might be a little skewed because I teach this class and I don't think it's too bad. Okay, so for number 7, the triangle whose vertices are 3, -1, 2, 4, and 5, 1 is transformed by the rule xy becomes 2x 5y. Is it similar or congruent to the original figure? So let's take a closer look at this rule right here. I'm going to highlight this even just so that, when I'm looking at it later, I'm like, where was the important part of that question? Aha, right here, 2x 5y. So this is multiplying. It's multiplying, but not by a consistent scale factor. So it's multiplying by different scale factor on x and y. So this is not a dilation, or not the kind of transformation dilation that we would use. Because a dilation would normally mean that this is going to be similar. And it's definitely not a rigid transformation, which would mean it's going to be congruent. So our answer is really going to be choice C down here, which is that the image is neither similar nor congruent. Neither similar nor congruent, because it's not a rigid motion and it's not an even dilation. So that's all for question 7. Now I did stick to question 1 at the end. So let's go back to question 1 and see if we can actually express this a little easier. I might use some of my information from this one maybe. So this was just on completing the square to find center and radius. So let's erase this part now and go and write some explanations. So you want to write Well, we're just going to say, sorry, that the goal is to write the left side as the sum, that just means we're adding them up, of two squared binomials. So what did we do first? We would first rearrange x and y terms, leaving space to add constants. Constants are just whole numbers. So we will rearrange our x and y terms, leaving space to add constants. And I would even say that constants have to be added. We'll say in a different color, any new constants must be added to both sides. Okay. Now we rearranged it. We left space to add some constants in. Now, how do we describe what we did there? Well, we divided the linear term by 2 and then square it. So to find the new constant, I'm going to cheat and copy some of my own handwriting. To find the new constant, we're going to copy this and paste it. Divide the linear term by 2 and then square it. Except I'm going to cheat now and I'm going to make this a lowercase d. All right. Divide the linear term by 2 and then square it. Now, you can rewrite as squared binomials. And then I'm going to say also be sure to combine all constants on the right side. Okay, so goal is to write the left side as the sum of two squared binomials. So first rearrange the x and y terms, leaving space to add constants. Maybe I should have said add constants to each. And then we're going to say any new constants have to be added to both sides. To find the new constants, we would divide the linear term by 2 and then square it. And now you can rewrite them as squared binomials. Be sure to combine all constants on the right side. So I know this does not help without actually showing an example. I am going to put C number 3 for example, since I already worked that one out now. And then, yeah. So hopefully you were able to write a good explanation of this. And if you missed anything and you were like, oh, well, that important step, then you can add that into yours. But I do want you to practice explaining this in your own words and not just using mine. So hopefully my explanations did help though. And if you do have any questions, be sure to ask your teacher in class, especially if your teacher is me. And yeah, thanks for watching. Again, this is the Unit 6, Lesson 6 Cumulative Practice Problems for Illustrative Math Geometry.